Okay, so for this problem, we want to find the critical points and the inflection points for the function natural log of x over x squared for when x is greater than 0. So we're going to start by taking the derivative of this function using the quotient rule, which is what Kenneth is doing now. Now he's taking the derivatives and canceling out all of the repetitive values. Now he's taking out the common variable x. And now he's setting it equal to 0, which is what you have to do for the critical points. Multiplied both sides by x to the fourth. Obviously it's 0 on the right side. You have 1 minus 2 natural log of x equals 0, which will give you x equals 0, or 1 minus 2 natural log of x equals 0. Find that x is equal to e to the 1/2. Okay, now we're going to find the inflection points of the function. So we're going to take the second derivative. We have the derivative right here. When we put Kenneth's here, so let's cancel out the common x's. The derivative of that function is equal to 1 minus 2 times the natural log of x times the derivative of x cubed minus x cubed times the derivative of 1 minus 2 times the natural log of x over x to the third squared. Now Kenneth is taking the derivatives of those values and canceling them out from each other. Okay, so first one is 0, just multiply x to the fourth times 0 to get 0. Now let's distribute the 3 out to get these values. Setting the function equal to 0 once again. Added the 3 to the 2 to get 5 minus 6 times natural log of x equals 0. Subtracted 5 from their side to get rid of 5. Natural log of x is equal to 5 over 6. So now you'll take e to the 5 over 6 to cancel out the natural log. You have x is equal to e to the 5 over 6. And this is the inflection point. Okay, so for this problem, we're trying to find the critical points and inflection points of the function f of x equals x times sine of x on the interval of negative pi over 2 and pi over 2. So first, Paris is taking the derivative of the function, which involves using the product rule. And these are the derivatives of the function as to when the product rule is applied. And after being added out, you get sine of x plus x times cosine of x. And you set it equal to 0 to find that x is equal to 0, which is your critical point. And now to find the inflection point, you take the second derivative of the function, which once again involves taking the derivative of sine of x and adding that to the derivative of x times cosine of x, which for that you'll take the product rule again. You get cos x plus, in parentheses, cos x minus x times sine of x. The two cosines add together just to give you 2 cos x minus sine of x equals 0. There are no inflection points because no value can plug into x to make these two equal to each other. So now you want to find the inflection point of the same function, e to the negative x times sine of x. And to do this, you take the second derivative, which, since we already found the derivative of the function in the previous problem, we just take the derivative of that function, which will be using the product rule and adding the two results together. So we find e to the negative x times sine of x plus negative e to the negative x times cos x plus negative e to the negative x times cos x plus e to the negative x times sine of x. And we're going to multiply all of these out to get the same value, just without the parentheses. Once again, you're going to pull out that common factor, negative e to negative x, to get negative sine x plus cos x plus sine of x. You're going to add all these together. Get rid of the negative e to negative x. Find that 0 is equal to 2 cos x, because the two signs cancel out. 0 is equal to cos x is equal to pi over 2, and that's your inflection point. Okay, so for this problem, you want to find the critical points and inflection points of the function f of x is equal to e to the negative x times sine of x on the interval 0 to pi. We're going to start by taking the product rule in order to find the derivative. So you get negative e to the negative x times sine of x plus e to the negative x times cosine of x. And now we're going to multiply that out to get negative e to the negative x times sine of x plus e to the negative x times cosine of x. you want to pull out the common factor, which is e to the negative x, to get cos x minus sine of x, and then e to the negative x is equal to 0. So you just cancel out e to the negative x to get 0 equals cos x minus sine of x, which you bring sine of x to the other side to get sine of x equals cos x. X is equal to pi over 4, which is your critical point. Okay, so now we're going to determine the critical and inflection points and the absolute and local maximum minimum for f when f of x is equal to x times e to the negative x on the interval of 0 to 3. We first want to find the critical points by taking a derivative of the function, and after applying the product rule we find that it is equal to 1 times e to the negative x plus x times negative e to the negative x, which when multiplied and added out gives us e to the negative x minus x times e to the negative x. We're going to pull out the common factor, e to the negative x, to get 1 minus x, and set that equal to 0. Find that x is equal to 1 and 0. These are our critical points. And now we can use these critical points to find our which one is the local max and which one is the local min. So we're going to use this number line here. And we have 0 and 3 on there also because there are the bounds of our intervals. Kenes is going to use numbers in between these values to figure out whether x is positive or negative at these points, or actually f, the derivative of x is positive or negative. And after plugging the numbers to the derivative equation, we find that it's positive between 0 and 1 and negative between 1 and 3. So we have a local max at x equals 1, and we have an absolute max at x equals 1 also, an absolute minimum at x is equal to 0. And to find the inflection point, you take the second derivative of the function, takes the product rule, and multiplies it all out. And then this equals setting equal to 0. Finds that x is equal to 2. So x equals 2 is our inflection point. Okay, so for this problem, we're trying to determine the critical and inflection points and the absolute and local maximum minimum for g, which is the function of g is defined as x plus 2 over x on the interval 0 to 2, where x is greater than 0 and less than 2. So first, we're going to find critical points by taking the derivative, which is equal to 1 minus 2 over x squared, so that's equal to 0.
Paris, just go left now.
Find that negative 1 is equal to negative 2 over x squared is equal to 2, and x is equal to plus or minus square root of 2. And these are your critical points. And now we're going to find the inflection points by taking the second derivative of the function. We find that the derivative is 4 over x cubed, which has no inflection points, so it does not exist because you can't have 0 in the denominator. And now we're going to find our absolute and local maximum minimum. Using number line again, our derivative function was 1 minus 2 over x squared. So we're going to find 0.5, which is in between 0 and square root of 2, a negative number, because 2 over 0.5 squared is a negative number, is greater than 1, so 1 minus that number will give you a negative value. And a number between square root of 2 and 2 is 1.8, where is a positive value because 2 over 1.8 squared gives you a value less than 1, and 1 minus that value is still positive. So x equals square root of 2 is your local maximum, or your local minimum, sorry.